Hi everybody, and welcome back to Research Methods 1. We are going to be talking about relationships between variables today. This is where it starts to get a little bit more exciting. Now we can start talking about how things are related to one another, which is, the whole point of research to begin with. So we're going to be talking about correlation versus causation today. And correlational variables are variables that are naturally occurring variables. Something like height and weight, they're already there. We can measure them, but they're already there. There might be a relationship between them, but they're already there. We haven't done anything to affect them. Something like self-esteem and depression, again, those already exist in the environment. We haven't done anything to manipulate those. We have simply measured those, and there might be a relationship. And in fact, there is a relationship between those. Let's see. So there's a difference between correlational variables, those that already exist in the environment naturally, and causal variables, where we think that one variable has an influence on another, or that when we make a change to a variable, it's going to make a change in another variable. I don't know if you remember what the name of those two variables is, or those names are. The independent variable is the variable in a causal relationship that creates a change in the dependent variable. So I manipulate my independent variable and cause change in my dependent variable. Now, it's really important to understand that correlational variables are often mistaken as causal. One of my favorite examples is something that a student brought in, saying that people who brush their teeth before they go to bed weigh less than people who don't brush their teeth before they go to bed. Therefore, toothbrushing before bed makes you lose weight. Do we think that that makes sense? Could there be another explanation for that? Well, so those are two naturally occurring relationships out in the world. How often do you brush your teeth, and do you brush your teeth before bed or not? Let's hope everybody does. It's a good idea. If you don't, you should start. And then weight is just something that naturally varies among individuals. So when they looked at those relationships, they actually inferred causality. They said, okay, well, if people brush their teeth before they go to bed, that must make them weigh less. In fact, the two are related, but it could be because of some other variable. So make sure that when you are reading in the media and on the internet and in stores and everywhere you go, people are going to be saying, oh, these variables are related, therefore that must mean that this one causes that one. And be on the lookout for it, because people do try to trick you all the time. And sometimes they just don't even mean to. They just automatically assume that. And even sometimes me, the research geek of the universe, sometimes I will even slip and say, well, clearly this one influences that one, so it seems like it's causal. But no, we've got to make sure that we do not infer causality from correlation. Okay, so correlational variables are those that are already existing in the environment, like height and weight. Causal variables are, or causal relationships, are those between variables that we think one is going to cause a change in another, our independent causing a change in our dependent, and those two are very different. Now, why can't we say that those correlational variables are causally related? I mean, surely there's, if you exercise more and then you weigh less, it seems like that would cause weight loss. We can't assume that in the absence of an experiment. We cannot assume causality. Experimentation is the only way we can be sure. And that's because correlational variables, because they already exist, could have a number of different reasons why that relationship is happening. First, variable A could cause variable B, so toothbrushing before bed could cause weight loss. Variable B could cause variable A. Being a lower weight could cause you to want to brush your teeth before bed, or there could be what's called a third variable problem, and that means that some third variable, like let's just say hygiene in general, or health awareness, causes both variables A and B. So when we have that third variable and we can't tell whether what that variable might be, it could be anything. That's just one example. You can think of one on your own, maybe a better explanation for why that relationship exists. That is a real relationship. It's a real correlational relationship, but I don't think it's causal, even though the newspaper claimed that it was. So think for a second about your own life and the things that you've read and the relationships that you've seen, and how often people say this, is related to that, and therefore it's a causal relationship. We're going to do an activity in class about that with headlines. Okay, so that's why we can't infer causation from correlation. So I wanted to talk to you a little bit about what a correlational relationship looks like. If you have a perfect relationship between two variables, that means you have one-to-one correspondence, and each variable is going to perfectly match the others. So as one unit of self-esteem increases, one unit of depression, actually I should be up here, as one unit of self-esteem increases, one unit of depression decreases, and so on. So it's perfect. Now, the self-esteem and depression is a bad example of that because it's not a perfect relationship. But as you can see here, these have lined up perfectly, and what that means is that things like the amount that you pay for gas and the amount of gas that you actually pump should be perfectly related to each other, and they should be positively related to each other. Positive correlations mean that variables travel together, either up or down together. Negative correlations, like this one, show that as one variable increases in value, the other variable decreases in value. So like self-esteem and depression, the higher your self-esteem, the lower your depression. The higher your depression, the lower your self-esteem. Again, we can't infer causality because one could cause the other could cause the first, or there could be a third variable causing both. So again, this is just correlational relationships, but when you look at a scatter plot of variables and their values, you might see something like this. In psychology and the social sciences in general, you tend not to get perfect relationships like here. This is more like, the pounds of fruit that you buy and the dollars that you pay for that. Should be a perfect correlation. You should not be paying more or less, here and there, give or take a cent or a dollar or two. It's important to make sure that you're paying exactly what you're getting for. The more you get, usually the more you spend. So there are perfect relationships, but in the social sciences, we typically don't get anything perfect. That's just because there's too much variability. People are just too different. Even from one moment to the next, our moods are different. Our temperatures are different, our tolerance for things, I guess our tolerability as well, how much people can put up with us varies from moment to moment. So you might see something more like this. Now, there are two things then to remember. Correlations can be positive or negative. And a positive correlation means that either increasing or decreasing together, the variables are traveling in the same direction. A negative correlation means as one variable increases in value, the other decreases. And so you're going to see lots of situations in life where there are variables that do this, but they are harder to think of and it's harder to conceptualize. So I want you to take a minute and think about two variables that you would predict would be negatively correlated with one another. And think about that and write that down, and we'll keep going in just a minute. All right.